All right, so we're on lesson 2-2, the coordinate system. And we've already looked at this, like I said, in chapter 1, but we're going to make sure we understand some other parts very well. The coordinate system. What I'm going to do is, toward the end of the lesson, I'm going to give you guys all graph paper to use for your homework and for the rest of the assignment, or the lesson. So I'll give those to you in just a little bit. But you can start in your own notebooks with the coordinate system. I want you to go ahead and draw me a coordinate plane. Now, Mr. A is doing this on blank paper, and you could do it on lined paper as best you can. Try it out as best you can, just like that. And we're going to label some parts and talk about some parts here. So go ahead and get that coordinate system put on. And if you're done with that, kind of waiting, look on page 72 and look at that map. What is the map of? If you can figure it out, raise your hand. What's the map of if you look at it there? Josh?
That's Columbia, District of Washington, D.C.
Okay, yeah, Washington, D.C., District of Columbia. Okay, what's dead center in that map? The capital. And by the way, how do you spell capital with an O? Oh, capital, not capital, right? So make sure you keep that straight. That's a little bit of vocab for you. Okay, you know what I'm really thankful for, guys? I'm thankful for the coordinate system, which we're going to talk about in just a bit. In fact, in my prayer, what I try to bring out is this, that I'm thankful for this coordinate system and the application of it. How many of you have ever been to like a big city, maybe Washington, D.C., New York City, Chicago, L.A.? I mean, you've been to different, maybe a big city. Okay, there's a way that the big cities are usually laid out. Are their streets like windy and curvy and all that? How would you describe their road system? Straight. We call them grid-like. Have you ever heard of like grid-like streets? Right here, Washington, D.C., or around the Capitol, do you guys see how they have A, B, C, D Street? They have 1st, 2nd, 3rd, 4th Street, all that. It's very nicely put. My wife and I, we went to New York City when we were like, I guess it was like 6 years ago now. And I remember we took a car to New Jersey, rode the train, I think, to New York, one of the subway stations, and we were there. And we were like, you know what, let's go walk around. Let's go get lost. So we walked down to the south side of the island. Is it Peninsula or Island? I guess, I don't know. But we went to the south side where you can see the Statue of Liberty, and we saw it. And then we're like, you know what, let's go to Chinatown. That's close by. So we went up to Chinatown, got lost, by the way, in Chinatown. We got lost where you're in the parts. No one is speaking English anymore. And the things that are hanging off the side of their stores, I still don't know what it was. I think they're maybe some type of alien creatures that were hanging. They were selling it for food. I was like, wow, that's amazing. We got lost there, then went up to Little Italy, then went somewhere, and this is where we were truly lost. We were at an intersection. I think it was like 30th and, I don't remember the cross street, but it was 30th and something, and we asked the police officer we saw, where do we go to get to blah and blah? And he's like, take a cab and go up so-and-so blocks to get there. We're like, great. Oh, we're going to walk, though. He's like, you guys are going to walk? I'm like, yeah, what's wrong with that? So we walked. We realized why he laughed at us, because that was a long walk. Out Central Park, that's where it was. So we went up to Central Park, and that was a long walk. We should have taken the cab. I should have listened to the police officer, by the way. Anyway, we're getting lost all over, but you know what? Did we ever really get lost? What do you think?
No.
You know why? Because how are their streets set up?
Like grids.
Like a grid. I'm lost here, so I want to get over there. Go this way, cut that way. And that's basically what we did. In Denver, it's a bigger city, has the same structure. Some of you have been to L.A. L.A.? That's a tough one. Don't drive in L.A. Some of you have been to Chicago? I don't think many people. Detroit? Okay, so some of you have been in different cities. They're laid out the same. It's very nice. You know what GPS is? And I've talked a little bit about it. Basically what they did was they made the entire globe this giant grid, which is super nice. Because you know how people used to get from one place to another? When I was a kid, you know how we did it? We would unfold this thing, and we look at it. Here I am. What is this called? A map. It was the hardest thing ever. I remember my parents would open up this map, and they would say, all right, we got to go this way, then that way, then that way. I'm like, what are they doing? I'm so thankful they had the map, and I didn't have to figure it out. And what happens when you got lost? You know what you'd have to do? Stop somewhere, open up the map, and then what? Find out where you are, good luck, and then find out how to get to where you need to go from there. That was really hard. What do we have now? GPS. And the reason GPS works is because the coordinate system. The whole planet is in this grid. So they can pinpoint me right here, and then they can tell me, all right, you want to get to Greenville, like downtown Greenville, which is right over here. Go here, 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 here. You got it. Okay? Now, does GPS mess up sometimes? Yes. Our connection, whatever. It reads the wrong thing, whatever. But for the most part, I am so thankful. Because it tells me, based on the grid, that I need to go this way or that way, or where I even am in the world. Guys, that was somebody taking this system and applying it, and how many of us benefit from that? Every one of us here. All of us, many times a day, maybe. Your parents are loving it. This is a blessing that someone took this system and applied it on a huge scale. So the things we learn in math, can you benefit others? Yeah, you can benefit the entire world. Or you can even just benefit your family if you learn some of these concepts, whatever the concept is. All right, let's look at some review here. We have two axes. The horizontal axis is called the what? Which axis? Which axis is it? Cole? So, sorry, this horizontal axis? X-axis. So I'm going to label it. Go ahead and label it X-axis. That is my X-axis. What is the vertical axis called? Chelsea? The y-axis, I'll put it down here, the y-axis. So we already know these things. What's the point where the x and y axes meet? The origin. So I'll put here origin, right there in dead center. Okay, good. All right, do you guys remember that last time we talked about quadrants? Do you guys remember quadrants? Okay, the first quadrant is located where? Excuse me, Davis. How would you describe it? Go ahead.
Top right.
Top right. So right here you put a Roman numeral 1. So remember, put Roman numeral, because if you just put the number 1, it could be confused with like an ordered pair. All right. What about the second quadrant? Where's that located? Sarah C?
It's
Top left. So right here, second quadrant. Third quadrant. Murphy.
underneath, left bottom.
Bottom left. Third quadrant. And last quadrant. I hope you get this one. All right. It's the IV, the fourth one. All right. So you guys should know those quadrants, I hope. When you have an ordered pair, which number goes in first? The X or the Y number? Always goes first. Always, always, always goes first. Matt? The X value. Therefore, which one comes second? Always? The Y value. The X value tells you, do you go right or left from the origin? And the Y value tells you, do you go up or down on the Y-axis? Does that make sense? Okay. It has to be in that order. If we mix them up, guess what happens? Some of you are here, some of you are there. Is that okay? Probably not. Okay. And I'm thankful that GPS does not mix these up either. All right. I want us to see some relationships. Somebody give me an ordered pair with two positive numbers. Two positives.
6 and 2.
Okay, so I'm going to put, you don't have to write this, don't write this down. 6 and 2. Okay, so 6 and 2. Which quadrant will that point be at? Nick?
Which quadrant?
Quadrant. The first quadrant, right? So when I start the origin, I would go 6 to the right and then up 2, so somewhere around here. First quadrant. You guys see that? In fact, let me give you this pattern, and then you're going to use that knowledge to figure out the other patterns. When the two numbers, the X and Y numbers, are both positive, which quadrant must it be in? Cole? First quadrant. Okay, ready? Let's test this out. I don't believe it. Peter, give me two positive numbers. Anything.
7 and 5.
Okay, 7 and 5. Which quadrant want to be in? Well, starting at the origin, positive 7, positive 5. Guess which quadrant?
No.
First. Okay, does anyone know where, which quadrant the point would be if you had two negative numbers? Two negative numbers. Now, first someone give me two negative numbers so I can visualize it. Parker, give me two negatives.
-4, -1.
-4, -1. All right. All right, so which quadrant does it have to be? And it's automatic, and it always will happen that way because that's how the system works. Alyssa? Third quadrant. I don't know about that. Let's check it here. So starting with the origin. -4, -1. Is that third quadrant? Okay. But that happens to work that way. Give me another pair of negative numbers. I want to test this out. I want to make sure it's true. Josh?
-3,
Ooh, good ones. -3, starting from the origins right here, -6. Oh, third quadrant. Okay, all points that have two negative numbers are going to be in which quadrant? Third quadrant. Does anyone know how to describe the second quadrant? Give me a general rule for the second quadrant. What do we know about X and Y? It has to be this way. And then we're going to test it out. Annie?
The first number will always be negative and the second will always be positive.
So you said negative then positive, right? Chelsea, give me a negative then a positive.
-3, +2.
-3, +2. So Annie, I'm going to put this to the test. -3, +2. Let's see. Starting from the origin, where do I go? I go to the left 3 and then up 2. Ooh, very good, Annie. That is the rule. Fourth quadrant. What is the rule? Fourth quadrant. Nick? Positive and negative. You sure about that? Okay, give me a positive and negative, somebody. Yes, Sarah?
7 and -3.
7 and -3. You sure about that, Nick? This is your last chance to change it if you need it. I'm giving you a chance here.
That is wrong.
Wait, no. Sorry, I thought I read the bottom.
That's okay. This one right here.
Yeah, that's right.
All right, 7, -3. Oh, that's the fourth quadrant. So let me tell you this right now. Is there a pattern with the point, the ordered pair, and which quadrant it's in? Is there a pattern? Does anyone have a question on that, though? Give me a good question here. I want to see if you guys are thinking. I see the patterns. All right, ready? This is what I want you to write down now. So off to the side. Here's the question I was looking for. What happens if the first number is 0 and the second number is anything else? Which quadrant will it be in? You're like, wait, is A positive or negative? It's either one. Which quadrant is it located in? What a great question. Peter?
It's on the line. It's on the axis.
Okay, how about this? Let's start with the origin. 0, that means I don't go left or right. And then A, if it's positive, you're here somewhere. If it's negative, you're down here somewhere, right? So which quadrant are you on? You're not on a quadrant. You know what? Where you're located? You're located on the y-axis. Y-axis. You know why I'm going over this, guys? Because you know what we're going to do to you? This is what we're going to do to you. Ready? See if you guys are paying attention. Which quadrant is the following point located? Ready? So which quadrant? 0, 3. Yes, Scout, I see that hand.
The y-axis.
What? I said which quadrant?
The y-axis.
Is that your final answer, sir?
Yeah.
Good. That's it. So if it's a 0, then a number, and in this case I gave you a positive, it's the y-axis. What if I gave you 0? Ready? -2. 0, -2. Murphy?
It would be on the y-axis.
Oh, yeah, I guess it would be. Yep, that's correct. So if I ask which quadrant, you're going to say y-axis. Okay? It's like a trick question. Ma'am?
Okay, so like if it was like 0, 3,
Mhm.
like we just did, how
It'd be
would
like-
it be like the first quadrant?
So 0, 3, wouldn't it be like somewhere right here?
Yeah.
So isn't it kind of between the first and the second? So you see I can go either way, but we say y-axis. All right. Tell me about it. Which quadrant is that point located on? Okay, on the count of 3, I want the answer. 1, 2, 3. I heard axis, and that's partly right. X-axis, yeah, I think most of you said it. It's on the x-axis. All right, guys. You know, I'm gonna kind of be straightforward with you right now. This is good to know, and you will use it today. But you really didn't have to know any of these quadrants and what the numbers relate to. You only need to know that for trigonometry. For most of you, 3 years from now, you'll need to know that. I remember when I was in trig, and I was like, I can't, yes, these are always in the y, and these are always in the x. I can't believe it. And now you already know it, right? Don't you know it? Yep. So when it comes trigonometry, trig, we call it trig. Basically, is studying triangles and right triangles and their degrees of their angle measurements and their side lengths. That's fun stuff. I might even pull some of that on you next year. But don't worry. Yeah, just you can wait a little bit. All right. Any questions on this so far? We good on it? Yes, sir.
What if it was 0, 0?
Jake, what a great question. Very good. 0, 0.
If I'm the origin.
You would say origin. Good. Good question. This would be origin. Would you say only x-axis? Would you say only y-axis? You would say origin. It's the origin. It's right dead center. Good question. Very good. I didn't get that last class. Good. Okay. Yeah, you guys are so bright. And you had the break to let out all that energy. Now the brain's flowing. All right, this is what I need you to do. I'm going to give you a graph piece of paper here. Take one, pass it back, please, and then I'll tell you what we're doing next to finish out this lesson. No. Thank you for asking, though. And eventually you will be, but just not for these first few lessons with graph paper. We're all going to be doing the same thing on the same paper. Oh, sorry, you need 3. Someone not get it? Oh, sorry, Peter. There you go. Okay, what you need to do with this graph paper is fold it into quadrants. Yeah, you can do hot dog and hamburger, if some of you are more familiar with that. So when it's all folded up, it should look like this, and then you unravel it. Okay, before you start drawing anything on this paper, this is not a giant coordinate system. It's not this big y-axis and x-axis. No, they're different blocks that I want us to have. So, yeah, you're going to use this paper for homework. All right, so this should be your paper. I'm just trying to show you what I'm doing. I had a graph paper. Okay, so you should, when you unravel it, have your quadrants. And this is what you're going to be doing. Please listen up so you're not confused. I want you to draw a coordinate system in the top left box. Do you understand what I mean by that? Please don't draw a giant coordinate system here. That's going to waste a lot of paper. And I'm going to blow that up in a nonviolent way and show it over here on the right, like what it looks like big. You draw in the top left box, you draw the coordinate plane. Okay, please follow this carefully because I think someone in the last class had a little bit of confusion. You're going to draw your little arrowheads. And, you're going to do your little tick marks, but you don't have to number them. Just follow the lines that they gave you. They should be evenly spaced. You don't have to go super far out because our numbers don't go that far out. Let me see here. You don't have to. You can, but if you want to look at it that way, but you don't have to. Maybe. Yeah, 5's good. 5's good. 5 each direction would be fine. Okay. And before we get into that paper itself, look at example number 1. We're going to do these verbally because they gave you the graph. And then we're going to do example 2 on this paper. So example 1, we're going to do it together, out loud. Okay, example 1. A, write the ordered pair for NASA. Find where NASA is and tell me how you would use an ordered pair to describe where NASA is. Where in the world is NASA? Do you notice what's in the center? What's dead center? What's at the origin? It's the Capitol building. And so where's NASA in relation to that? Okay. Just a moment, I'll get your answers. Where is, and you're looking at example number 1, and they gave you a nice grid. So you can find where NASA's at. Give you about 15 seconds. Where is NASA?
I found it.
NASA is right there.
I know. I thought you were.
Oh, no, you don't have to put it here. No.
Okay.
There you go. Yeah, it's on example 1.
Wait, we can write it down?
No, we're going to do this verbally. Okay. Yes, Rachel, I see that hand. So where's NASA on example 1?
In the third quadrant.
Okay, it is in the third quadrant. And what's the ordered pair that gives us where NASA's at? How about Laura? That's okay. Double check it. And you're going to check it with...
6. No, -6.
Okay, from the origin, you went -6, -3. Is NASA located around here? Yep, that's where NASA's at. Good. -6, -3. Is that what you got, Rachel? Everyone else? Any questions on that? Good. I'm glad you're getting those. By the way, does it matter which number comes in first? Do you have to put X and Y, or can you just switch it up? You have to put an X and Y, because this is what happens. Hey, from the Capitol building, go 6 miles, and I'm just making things up. Go 6 miles to the, west, and then go south 3 miles. Oh, oops, I'm so sorry. I meant 6 south and 3 west. I'm so sorry. Oh, yeah, that's okay. I did not have to drive back to where you're at. Doesn't matter which ones you put first. Yes, because that means a lot, especially with directions. Okay, B. What is located at the ordered pair 2, 3? 2, 3. Okay, Chelsea. The Senate offices. So you see you go 2 east, 3 north, Senate offices. And what is located at the origin? What is at the center of it all? Sarah C? The Capitol building. Capitol spelled with a? O. An O. Very good. Capitol. Capitol building, capital of a city, or excuse me, of a state. Okay, now let's look at example 2, and that's where you're putting it up here. So up here you have example 2. That's what we're looking at right now. And like I did, I enlarged it here so you can see what I'm doing. Okay, example 2. All right, graph each point on a coordinate plane. Ta-da! Then name the quadrant in which each point lies. Okay, so A is D, and D is -3, 4. Is that it?
No, it's -4.
3, -4. Thank you. Let me make sure I get that right. So 3, -4. All right. 3, -4. I'm sorry. All right, so how do I get to 3, -4? Starting at the origin, where do I go? Cole.
To the right.
I go to the right 3. 1, 2, 3. And then? Down 4. 1, 2, 3, 4. All right, I'm going to put the letter D there. Okay, I have to label it D. That tells me that's where point D is. And then what else did they want to know for point D? Do you remember what they say? Yes, Annie?
What quadrant?
What quadrant is D located at? So what quadrant is that? Fourth. So you put next to it IV, 4th quadrant. Okay? All right. Yes, ma'am.
Where are we looking?
Example 2 on page 74. So we just did A. B, I'm looking for E, -3, 2. -3, 2, and that's point E. All right. So somebody else tell me, where do I go from the origin for -3, 2? Sarah.
You go 3 spaces left.
So I go 1, 2, 3,
Then up 2.
1, 2. So up here?
Mm-hmm.
And then what do I do at that point? I also label it with the letter E.
Then it's in the second quadrant.
And then I have to say it's in the second quadrant. Okay, it's in the second quadrant. So far, so good. Pretty easy, right? Not too hard. This is the base. This is the half of your homework, I would say. Okay, and then C, which is F40. So I'll put that up here. F40. Okay, so show me how to get to 40. Josh.
You go the right 4 times.
1, 2, 3, 4. And then what?
Stop.
Stop. Oh, 0. Yeah. Okay, so I label it with F. Which quadrant is it in? Matt?
First.
Seems like it's the first, right? But doesn't it kind of look like it's in the fourth? So there's got to be, I don't know, which one do I feel like today? First or fourth? But is there a better answer? Alyssa? You would write x-axis. Remember, it's on the line, so you write x-axis. That's the answer. Which quadrant is it in? It's in neither of them. It is in the x-axis. You guys get how that works? All right, how many of you did that on that top left of your graph paper? Good. Okay, I'm going to give you your homework assignment. It's going to be, and so you can write this at the top of the paper or wherever you remember it. It's 14 to 36. Page 75. Okay, look at 14 to 23. What does it say to do there? 14 to 23. Name the ordered pairs. So what you're doing on your homework is this. You can do number 14 here, number 15 here, number 16. You don't have to graph them. You just have to give me the ordered pairs. Okay? You can do that all the way until you're done. If you need this side, you can do it. All right, but look at numbers 24 to 35. What does it say to do here?
On graph paper, draw coordinate axes, and then graph and label each point.
And then name the quadrant which each point is labeled. Okay, there are, there are 12 problems there. Some people ask, can I do it all in the same coordinate plane? You technically could, but that gets cluttered. So for 24 to 35, you're going to split that up into 2 coordinate planes, okay? 2 of these coordinate planes. For example, I might start here. And I'll do numbers 24 to 29 on the first one. 24 to 29 here. And then I'm going to do 30 to 35 down here on another coordinate plane. I want to split it up because I don't want it to all be smashed into one coordinate plane.
Does it matter what area we do our problems? Like for 14 through 23, does it matter what section?
Yeah, do it in the second section. And if you spill into the third section, that's okay. You're just going to have to make the first graph here, and then the second graph would be on the back. Yep, you can use the back. Number 36 is a unique one. Graph each point, then connect the points in alphabetical order. So you're going to graph the points, then connect them, and you're going to find a little shape there. Identify the figure. Okay, number 37. Look at that one. Oh my. Yeah, I said 36, but look at 37. Isn't it long? Isn't it tough? I'm going to give you 3 bonus points if you can successfully do number 37. That's an extra one. It's a bonus one.
What?
37 is bonus. 3 bonus points on homework. I would do it. You're like, well, I don't know. Just do it. Just try it. If it's fun, the message is going to be, math is awesome. Unfortunately, it won't fit it all. So, no. 14 to 36 is your homework. 37 is a bonus. You don't have to do it. You can try it. And if you try it and mess up, that's okay. I might give you 1 bonus point. If you do really well, but just barely get it off, 2 points. So you can get some partial points as well. 14 to 36, that's page 75, and you have the rest of the time to work on it and to finish it up at home. Thank you, Swivl.